Hello everyone, welcome to RoshChem summary videos. In this video, I'm summarizing the lesson gravimetry. So what is gravimetry? Gravimetry is the quantitative analysis by mass. Okay, so we can use gravimetry to find the salt concentration or the percentage of salt in a given sample. So we look at the steps involved first. So for example, you have a sample of Vegemite and you want to find the percentage of sodium chloride in that. So these are the steps involved. The first step, weighing the sample to be analyzed. So you take the weight of the sample given, dissolve the sample in water. Insoluble material is filtered off. If there is anything which is not soluble, you remove them by filtration. Add in excess of suitable chemical to the filtrate to form a precipitate. Okay, so what is this suitable chemical here? So now, I'm doing this, I'm doing this experiment to find the sodium chloride content in a sample of Vegemite, right? So I want to find NaCl percentage. So I have to add another chemical to precipitate NaCl. So I can add silver nitrate. So when I add silver nitrate, so I know that I can precipitate the chloride ions as silver chloride because silver chloride is insoluble. So your reaction is then you get sodium nitrate and silver chloride, and you know silver chloride is insoluble. So that's why we add excess of a suitable chemical to the filtrate. So now your filtrate contains sodium chloride. To that filtrate, you add silver nitrate in excess. Why I add in excess? To make sure that all of the sodium chloride is reacting so that you can get a precipitate. So which means by doing that, you precipitate all the chloride ions present as silver chloride. So filter in to collect the precipitate. So by filtration, you can collect the precipitate and then you rinse the precipitate with water or a suitable solvent. So why we have to rinse the precipitate, you can see. So now with the precipitate, you have sodium nitrate produced and also you added excess of silver nitrate and there can be other impurities. So by rinsing, we get rid of all these impurities, right? So then you get a pure, so that you can get a pure precipitate. And then repeated drying and weighing until a constant mass of the precipitate form. To make sure there's no water, you have to heat it, you have to dry it until you get a constant mass. So that is, so then based on the mass of the precipitate you obtain, right? So you need to get the mass of the precipitate. So if you know the mass of the precipitate, right, you can do a stoichiometry calculation and you can find the mass of the sodium chloride. And from the mass of the sodium chloride, we can find the percentage of sodium chloride. So in gravimetry, what we have to do, then we have to make a precipitate and you have to get the mass of the precipitate, and using the mass of the precipitate, you find the mass of the other chemical using stoichiometry. So then you find the percentage. Okay, we'll look at a question involving gravimetry. Okay, so look at this question. Sulfur dioxide is often used as a preservative in food industry. The sulfur dioxide content in dried apricots can be determined by gravimetric analysis. The steps are given below. Okay, so step 1, the dried apricots were crushed to a powder. Then 120 gram of the powder was put into a conical flask containing 500 ml of deionized water. So you put the dried apricot, you have taken 120 grams of it, that is your sample, you dissolve that in water. A solution of hydrogen peroxide was added to convert the dissolved sulfur dioxide to sulfate ions, right? Now what we do, the dried apricots contain sulfur dioxide. By adding hydrogen peroxide, I convert SO2 to what? The sulfate ions, SO4 2 minus. That's what's happening in step 3. Then step 4, an excess of barium chloride solution was then added. Barium sulfate precipitate was filtered off. What happens now to sulfate when you add barium chloride? Right? When you add Ba, Cl2, which contains Ba2 plus. You will get a precipitate of what? BaSO4. You get a barium sulfate precipitate, a solid, right? The precipitate was filtered off, dried, and weighed to a constant mass. The mass of the barium sulfate precipitate was 0.929. So the mass of it is what? 0.929. Right, so I use this to calculate the percentage of sulfur dioxide. Okay, now we will see how do we calculate. Okay, so first it's asking your balanced half equation for the conversion of sulfur dioxide to sulfate ions. So here you can see SO2 is going to SO4 minus, so I can use the Cohe's method to balance this equation. So key element is sulfur, one sulfur, then O means oxygen. So I have 2 oxygens here. So I have 4 oxygens, therefore I need 2 more oxygens this side. To balance oxygens, I'm using water. So that's why I put 2H2O here. So now I introduce 2 oxygens to that side. So now how many hydrogens I have? 2 times 2, 4 hydrogens. So I can write then 4H plus because to balance hydrogens, I'm using H pluses and then 2 electrons. So how many electrons now? This side no charge. The other side is 2 minus and 4 plus means 2 plus. Therefore, I put 2 minus, which is 2 electrons to balance that. Right, so that is the oxidation of sulfur dioxide to sulfate ions. Give a balanced ionic equation to represent the precipitation of barium sulfate. Okay, ionic equation, which means we don't write the spectate ions. Barium sulfate contains Ba2 plus. So reacting with sulfate ions to give barium sulfate precipitate. So this is your ionic equation for the formation of BaSO4. So what is the ratio? Its precipitate is BaSO4, it's 1. Sulfate is also 1. So 1-to-1 ratio with barium sulfate to sulfate ratio is 1-to-1. Explain why barium chloride was added in excess in step 4. So why did you add barium chloride in excess? That is to ensure that all of the sulfate ions are reacting. So you can see sulfate and barium 2 plus are reacting. So barium 2 plus came from barium chloride, right? So by adding barium 2 plus or barium chloride in excess, I can ensure that all of the sulfate ions are reacting. To ensure all of the sulfate ions present in the solution is reacting to give the precipitates. That's your answer. Okay, calculate the percentage W to W, so weight to weight percentage of sulfur dioxide present in dried apricots. Okay, so the first step is to find the moles of barium sulfate, which was your precipitate. The mass of the precipitate was given, divide by the molar mass, so you can get the moles of the precipitate. Okay, so then what is the molar ratio? Asking for what? Sulfur dioxide. So what happened? You had sulfur dioxide, it went to sulfate by oxidation, and then sulfate became BaSO4. Sulfate became BaSO4. So what's the ratio here? So you can balance in terms of sulfur atoms. So 1 sulfur, 1 sulfur, 1 sulfur. So it's 1-to-1 ratio. So if you know the moles of BaSO4, moles of sulfur dioxide is also same 0.00398 moles. It's 1-to-1 ratio everywhere. So then I can find the mass of sulfur dioxide. How do you find the mass? Moles times the molar mass. This is the mass of sulfur dioxide. Then you can find the percentage of sulfur dioxide. Percentage of sulfur dioxide is equals to what? Mass of sulfur dioxide divided by the mass of sample, because it's asking calculate the percentage weight to weight. So W to W means this is the mass of sulfur dioxide divided by the mass of the sample. So what's your sample? Dried apricots. You took 120 grams of it for the precipitation, right? So it's 0.255 divided by 120 gram sample times by 100 to make it a percentage. So then you get 0.21%. What is the concentration of sulfur dioxide in ppm? So this is the percentage. It's asking what is the concentration in ppm? So what is ppm? How much of sulfur dioxide is present in parts per million? So parts per million means 1 million parts. So I can say now here, so percentage means what? If you take 100 grams of sample, so then you can find 0.21 grams of sulfur dioxide, that is percentage. If I take 100 grams of sample, I can find 0.21 grams of sulfur dioxide. So when I want to express that in parts per million, you should use 10 to the power 6 or 1 million grams of sample contains what? Contains then 0.21 divided by 100, right? So you times by 10 to the power 6. 0.21 divided by 100, you multiply it by 10 to the power 6. Or else there is another method to do the same thing. So in here, what is the concentration of sulfur dioxide in ppm? So I took 0.255. So this is 0.255 is the mass of sulfur dioxide. That mass is present in 120. So 0.255 divided by 120 will give you how much of sulfur dioxide is present in 1 gram, right? Then you multiply it by 10 to the power 6, so that you will get the same answer, right? So you can find the ppm value using the percentage you obtain here. So percentage means out of 100 grams, 100 grams contain 0.21, therefore 10 to the power 6 contains what? Or else you can even find the ppm value using this answer, which is 0.255 was present in 120. So you divide by 120 to see how much is present in 1 gram, and then you multiply it by 10 to the power 6. That both will give you the same answer. Okay, so that's the end of the video. So now it's time to do questions. You can find questions and summary notes on pages 107 to 113 of RoshChem 1 and 2 study guide. Okay, so thanks for watching my video. If you need any further information, please visit our website, www.roshchem.com. I'll see you in another video. Bye.